Welcome to our second official unit of the year. This one is on heat and energy. Don't forget that while you watch the notes that you need to fill in the notes packet and also be ready to take the 12-question video notes quiz. This time it will be going in the grade book, so please don't forget to take it. I know a lot of you didn't take it last unit, but make sure you don't forget this time. This unit has a lot of important information in it, so make sure that while you are taking your notes, you are pausing when you need to, rewinding if you need to. That's the best part about taking these as video notes, is that you can go at whatever pace you need to. So please utilize pausing and going back if you miss a blank. So first up, we're going to talk about the forms of energy. Energy itself is the ability to do work. We have two main types: kinetic energy, which is the energy of motion, and potential energy, which is stored energy. You learned about both of these last year, so this should just be a review. What we have next is the more specific types of energy. So kinetic and potential are our big, broad kinds, and then within kinetic and potential, we have more specific ones. So first up, we have nuclear energy, which is found in the nucleus of an atom. Some examples that we have of these are nuclear power plants. This is not just any power plant. This is specifically a nuclear power plant. And then also the core of the sun is made up of nuclear energy. Next is thermal energy, which is the total kinetic and potential energy of all the particles in an object. So the total moving and non-moving particles that are in an object. It can also be called heat energy. Next, we have electrical energy, which is just what it sounds like. It's found in electric charges, so anything that uses electricity, and also lightning. Then we have electromagnetic energy, which travels in waves. Visible light is electromagnetic, UV rays, and also microwaves are all electromagnetic energy. Mechanical energy is the kinetic plus the potential energy. It's movement. So it takes into consideration how many particles are moving and how many particles are not. So chewing, walking, anything that requires movement is all mechanical energy. Chemical energy is when chemical bonds within an object break. The easiest example of this to think of is when you digest your food. So your body is breaking down the bonds in the food that you ate and giving you energy, and that energy is chemical energy. This is also found when you light a fire. So when you strike a match, that's breaking bonds in the match head, which is releasing chemical energy. Our different forms and types of energy can transform from one type to another in what we call energy transformations. The law of conservation of energy tells us that energy cannot be created or destroyed, it's only transformed or changed. So it'll change from one form to another, but you're never going to create new energy or destroy old energy. All forms of energy can be transformed into other forms of energy. For example, in a hydroelectric power plant, the mechanical energy, which is movement energy, that's found in the moving water, is transformed to electrical energy as the turbines generate electricity or electrical charges. This is a single-step energy transformation where just one form of energy is transformed to another. Another example we have here is your body transforms the chemical energy that you get from digesting the food you ate, and it transforms into mechanical energy that you then use to move your muscles. Most of our energy transformations are going to require more than just one step. So most of them will have multiple transformations that they go through. An example of this is that in a car engine, electrical energy produces a spark. The thermal energy from the spark releases the chemical energy in the fuel because it heats up the fuel and breaks the bonds that are found in the fuel, which causes the fuel to expand. Eventually, it expands enough that it causes the wheels to turn, the wheels that are located in the engine, transforming the chemical energy into mechanical energy, because once it's moving, it is mechanical. So when your car starts moving, you have ended up with mechanical energy. You can even take it a step further, because when you then press the brakes to slow your car down, you notice that it gets warm. And that warmth is caused by friction, which is two objects rubbing against each other, and that is generating heat. And we know that heat is thermal energy. Another example, you take a bite of a banana using mechanical energy, the chewing. Your body digests the banana, and breaking down those bonds is transforming it to chemical energy. You then decide to go on a bike ride. Your pedaling transforms the chemical energy into mechanical energy because you're moving. Once your body heats up and starts sweating, the energy is transformed to thermal energy. The next part of this unit talks about the difference between thermal energy, heat, and temperature because they all seem very similar. So first, our thermal energy, we already learned about it. It's our heat energy. It measures the total energy of the molecules, both moving, which are kinetic, and non-moving, which are potential in the object. So it takes into consideration how many particles are moving and how many particles are not. Heat is the transfer of thermal energy from hot objects to cold objects. And that is really important. So make sure that you are remembering that. So if you want to star that in your notes, it's probably one of the more important concepts. Temperature is the average kinetic energy in the object's particles. So thermal energy was the total kinetic and potential. Temperature is just the average kinetic. We have an acronym to help you remember this, and the acronym is TAKE. So the T stands for temperature, the A is average, K is kinetic, E is energy. So if you can remember TAKE, you can remember what temperature stands for. So temperature is the average kinetic energy. So there are different ways for heat to transfer. First, a reminder from the last slide is that heat is when energy is transferred from a warm object or hot object to cold objects. It always goes from hot to cold. So remember that. The heat will stop flowing when the two temperatures of the objects are the same. So if you put your hand on a desk or a table and it feels cold, if you leave your hand there long enough, eventually the desk will feel like it's the same temperature as your hand. That's because the heat or the energy is flowing from your warmer hand to the colder table or surface. And then once they're the same temperature, it'll stop flowing. So that's why it wouldn't feel cold anymore. There are 3 different types of heat transfer. The first one is convection, and this occurs in fluid like water or air. So you may notice that if you've ever slept in bunk beds, if you're on the top bunk, you may get a lot warmer than if you're on the bottom bunk. That's because the hot air or water rises, and then once it cools off, it sinks back down and heats up again. So if you'll notice the little picture of the house that has the heater, the hot is rising, cold is sinking. Same thing happens when you boil a pot of water. So the heat source is at the bottom. The hot water, once it's boiling, will rise to the top. And the reason you see those little bubbles when it boils is because the hot water is rising all the way to the top and popping like in a little bubble. And then it sinks back down when it cools off to get warmed back up by the flame at the bottom. And then it goes back up. And it keeps continuing in a process like that, which is why it shows the little circles. Next, we have conduction, which is from one particle of matter to another. So you'll notice in conduction, there's the letters D and C. Easy way to remember this is that the D stands for direct and the C stands for contact. So it's direct contact, not direct conduct. But direct contact is conduction. So if you're touching something directly, it is conduction. So an example here is if you touch a hot pan with your hand, you are using conduction. Or when I had you do the putting your hand on the desk earlier in this slide, that was conduction because you were directly contacting the table. Our last form of heat transfer is radiation. And this is the transfer of waves from electromagnetic energy. And this is the only one of our heat transfers that can occur in completely empty space. So what we mean by completely empty space is like outer space. So the way that the heat and the light from the sun gets to Earth is through radiation, because conduction and convection cannot travel through completely empty space. It has to have particles of something, which we'll talk about more on the next slide, what I mean by the particles. But in outer space, there is no particles, so it's completely empty space. So the only type of energy that can travel there is radiation. Our last section for this unit is the states of matter. So you should be familiar with these because you've learned them before. but matter can change shape by adding or removing heat. So our three states are solid, which has a definite shape and a definite volume, meaning that it's always going to be the same shape and take up the same amount of space. The particles are closely packed together and cannot move around very much. They move a little tiny bit, but not a lot. So think about if you were in a super crowded elevator. You aren't going to be able to move as much as if you were in an empty elevator. So if you were in an elevator that was completely full of people, it would be like you were a solid, because you can move a little bit, you can wiggle your hands, but you can't spin around or run around or anything like that. Next is a liquid. Has a definite volume, so it always takes up the same amount of space, but it does not have a definite shape. So you can pour it and it'll take the shape of the container. The particles are packed together still, but they can move more freely than a solid can. They have more kinetic energy. So think about if you were in an elevator with like 2 or 3 other people. You can move around better than you could in a packed elevator, but you still can't maybe move as much as you would want. And then last is a gas. Gas has no definite shape and no definite volume, so gas kind of does what it wants. Particles are not closely packed at all and can move freely, and they have a lot of kinetic energy, meaning they can move around a lot. So think about if you were in an elevator completely by yourself. You can really do cartwheels, you can spin around, whatever you want in that elevator because there's nobody else in your way. So here is kind of a visual of what these look like. The gas particles are spread out quite a bit. The liquid is closer together, and then the solid is jam-packed. So that's kind of what it looks like there. So when you add heat, you are going to go from a solid to a liquid to a gas. So think about when you have an ice cube. When you add heat, it melts to a liquid. If you continue to add heat to that liquid water, it would evaporate and become a gas. So adding heat causes those particles to speed up and move away from each other. If you remove heat, so if you take liquid water and you put it in the freezer, you're removing heat. And that's going to cause all of those particles to squeeze together and become a solid ice again. So it's going to cause those particles to squish in and stop moving as much. Think about it as if you're trying to bundle up and get warm. You aren't going to move around as much because you're trying to bundle up and stay warm. So that's going to make it a solid. So I hope that this helped. Reminder that you can go back and rewatch any part if you missed blanks. We will go over it in class tomorrow. Also, make sure that you take the 12-question video notes quiz. Do not forget because it is going in the gradebook this time.